Well, I'll be giving you another one of these things to fix. Let's get into it. I believe this is one I've actually looked at previously. That's what I've been told anyway. Apparently it's giving an error message of some kind. I don't know what that is. There was no description about what the error message actually was. Now, if I remember rightly, when this failed before, it had multiple faults. I've worked on a few of these now, so I'm not sure which one it actually is. I have to look it up. But it looks like I have... Yeah, this is one of my repairs here. I've redone these connections. That still feels good. So does that one. They feel alright. So, anyway, we'll hook up my test jig and see what it says. Don't forget to click like and subscribe, which will probe it at the same time, and then see what voltage we get, if anything, out of it, and if we get any errors come up as well. We'll see what happens. Right, let's give it a go. We don't have any power. Well, that's interesting. It's completely dead. So much for error messages. There's a reset down here, isn't there? That's pushed in. Let's try again. It's just completely dead. That's interesting. Well, I guess we're going to be pulling it apart instead then. I've unplugged the power, obviously, because that would be silly to open up with that still plugged in in case something is floating around inside, you never know. First time I've had one which is completely dead like this. And if you don't know what this is, so this is an Akatherm CB160, which is an electrofusion welder. This is used for welding polyethylene pipes together. I've done a few videos on these, so if you're interested in these things, you can check out my playlist. I do have playlists for these things. So, let's see what we can see here. We have the reset here, obviously, but that is pushed in. Flex hasn't been pulled out. Cables look intact. Power switch cabling looks intact. I need to figure out what's going on here, because why is there no power? That's rather curious. So let's just probe around here, plug it back in, see if we get any voltages around here. I just found this little screw on my desk. Where did that come from? Why is there a screw that's appeared from somewhere? I'm looking now to see if we can find out where it's come from. That's puzzling. It's also like a... Is that security or is it hexagonal? Hexagonal, I think. Yeah, it's a hex countersunk screw. Where does that come from? Because there's nothing else like it here. That's weird. Well, there's definitely no obvious places that screw could have come from. I can't see anything in here. There's nothing like it. All the other screws are crosshead, or they're nuts, you know, instead. So I don't understand where that screw's appeared from. It's also kind of concerning. I mean, where did that come from? Let's just investigate the circuitry here a little bit before we get into it. So, mains cable comes in. The phase comes through this overload here. Loops through. The neutral goes straight up. Both cables come up here to the switch, that's switching both the phase and neutral together. Good safety option. Then it comes back down to the circuit board here. So all I've really got to do is check this board, and that eliminates the overload and the switch. So if I just measure right here when it's turned on, that should tell me if there's at least power getting to the board. Okay, switch is currently turned off. We'll just do this for the sake of completeness. Nothing there. We'll turn the switch on. Recheck. We have power. Okay, so we've got 240 volts coming into the unit. This is still dead. It is still dead. Okay, more investigation. This wire is flapping around. It's purely for the stop-start button, so it doesn't affect anything right now. That's why I'm not worried about connecting it back up to give me some movement here, the casing. So obviously the reset's okay, switch is okay because power's getting to that point. So we've eliminated two things already. Why is this dead? I mean, if that screw here was floating around inside the casing, maybe it shorted something out and blown the power supply. So let's see what we can figure out from power supplies. Now it does have some regulators both sides, it's got one each side. So let's see if we can measure something on those. See if there's any life on them. Actually there's a big rectifier down here too, let's measure across this. 21 volts across that big rectifier, so that's promising. Okay, let's measure this one. 6 volts. So this one's given 6 volts, 7 out of 6. And the voltage coming in, 10 volts. This is 7906 as well, so it is 6 volts. So there should be 6 volts here. Let's just peel this up and check both sides. 11 volts coming in. And 5 volts coming out. That's curious. Okay, let's put it this way measuring. I've just gone to this post here, and if I go to that pin there, I'm getting minus 6 volts like I should be, and I go to this one over here, I'm getting plus 6 volts like I should be. So those regulators are working alright. It's obviously just the the way they've got these set up on here for the isolation and what have you. So it's why it's measuring a bit weirdly, but relative to that post, then it's all correct. So why is it still dead? So when I flick the power switch on, if you watch these LEDs, you'll see, I have it capture on camera, they all light up just for a very brief second. Oh, instant, you know, it's not a second, but it's 10 milliseconds, something. You see it? So there is some kind of life from the microcontroller. So it's obviously, microcontroller is doing something. Not doing it now. Of course it's not. It's done it a few times, I've seen. There you go, I did a little bit of sand, red ones, so it is doing it. There is something happening. There is power in the microcontroller, but that's it. I'm concerned there may be a problem with the microcontroller. Maybe that's been shorted out. It's not hot, nothing's getting hot, but no life on LEDs, that can only really come back to being the microcontroller if all the voltage check out, which they seem to. There are a couple of solder joints around it which look a bit dodgy, so on that side especially. But that's on the output board and stuff. I think maybe it's a problem, but I'll pull this board out and I'll check for bad solder joints, especially these connectors, things like mechanical stuff, where they've got mechanical stresses put on them, they can break. Maybe there's an issue there, but yeah, I'll just go around and check all the solder joints and see if there's anything bad and see if that brings it back. But right now it's not looking very promising. Just curious about where that screw came from. So here is the bottom of the main board, the actual one the power supply comes into, where the mains comes in. Obviously got some MOVs and stuff in here. That all looks fine. So it's got this wire which is soldered on here, which is a second primary, which comes up to this transformer and runs over up here. So that's two separate supplies basically. Nothing looks bad on there, at least not at the first glance. Now pull this one apart and see what that looks like. Okay, take these nuts off here. Interesting arrangement. These have all got these insulating fibre washers on them as well. The other screws did as well, which are just over here. That's where that screw came from. There we go. It's on these posts. It's come loose and fallen out. And there's another microcontroller. Oh dear. This isn't good. There you go, so there's the back of that board there, and as you can see, there's the matching screws, and look, this one's also falling out. And here's the one which fell out of the casing. This one here. So obviously this one here fell out, which has come from this point, and it shorted some stuff out. So it could have done anything, and it's likely it's fried this. And I was assuming this is a microcontroller, because it doesn't, you know, over here, I thought that was it. So that was a microcontroller there, but I don't know, I've never actually looked it up. I was assuming that would be all it is, because it's not really that much required, and these things are pretty simple things. But then you've got this massive microcontroller on the back of this. So this is the one that's obviously controlling it. Maybe that's not a microcontroller after all over here, maybe it's something else. I should probably look that up now and be sure what that is. With all the LEDs being off and no life, maybe it's blown a power supply, maybe it's, you know, shorted a blown a resistor or something on this board or something like that. There's a diode over here, some diodes here. I'm not seeing any burnt ones, but I might have to look under the microscope. It's concerning. That's why you should always do your screws up tight. Oh, nice a tight screw. So let's just put these screws back in again. There's nothing underneath there to see anyway, so I'm just going to put it back together. It's just holding a transformer block on with the sub power supplies. They use tapered screws for some reason, so yes, it is bobbing me out. Maybe that's why it's not actually held down that well. So those two there are done. Let's check these. Yep, that's loose as well. Check this one. Oh, that's also loose. Wow. Even the screws which were holding in the main board on this, like this board over here, the screws holding this in were also fairly loose. They weren't that tight, but they were going into plastic, so you know, you kind of expect it to be a bit flaky. But that wasn't good. Maybe it's been exposed to a lot of vibration, it's just shaking it all loose, I don't know. But so I need to do some testing around here so I can find any blown parts, because something is obviously dead. It's not happy. Who knows what damage this has done. So I'm just looking around, there's one resistor here which looks slightly dark on this end. Could just be flux residue, just measure it. Using my Pomona precision leads here. So they gifted me quite nicely. Be doing a review on these. There we go. So 1202, and it's coming up as 11.8K. So 1202 is 12, 0 with 2 zeros on the end. So that's 12k. So that's fine. That one's okay. I'll keep looking. I couldn't visually find anything. Let's go around and do some testing of diodes. There's a couple of diodes over here. Check these. That's fine. That's fine. Just looking for the big ones first, and we'll look at the transistors and Zenas. And that's fine. Fine. And then up here. It's fine. So we've got some here marked as Zenas, ZD, ZD2. I'm not sure what the actual pinout is of these. We'll just probe around so we can find anything. Okay, well, it's doing something, so it seems alright that way. I think there was another one, so it's ZD1. Doing the same thing, same behaviour. Hands on voltages, obviously. Nothing obvious. I think that's all those basic parts I can check. Let's check for shorted caps. Yeah, it's fine. This one here. Fine. Just in case there's been a physical damage from that screw floating around, it's been pressed or something and cracked a capacitor. Possible. That's fine. Not likely, but possible. Kind of rule out the simple stuff. But I'm suspicious that what's likely happened is it's probably blown the microcontroller because it shorted it out. That'd be what I'm expecting. Okay, I think that's all those. So yeah, I can't really fault that board. There's nothing obvious there. Oh well. Damn. Well, there's one more inspection we can do, and that is to check the chips for any blowholes and stuff like that, in case any of these chips are blown up. That one there seems fine. Lighting's always hard to get on these things. There you go. No obvious issues there. Next chip. No holes. No, looking alright. Next one. No apparent holes. Be able to see the lightings on them. That one seems fine as well. Can't see anything. There's no one over here. It also seems fine. Yeah, nothing there. Well, let's peel the sticker off and see if there's anything underneath this. In case that's blown as well. It's possible. Well, that looks fine. I can't see any holes there either. Is there something just there or not? Is that just a mark? Just there. No, that's fine. Well, no obvious damages. Check this out. So I've measured every resistor on this board and that sort of stuff. Can't find anything physically wrong. At least not yet. Let's try this. Let's turn this on. You see those LEDs just flicker just then. Nothing's on. If I go around and touch the circuit board, nothing there. Nothing there. Nothing there. Nothing there. Not hot. Oh look. I touch this right there. The LED comes on. I want to find if that chip's coming out. That side flush. This side isn't. That could be it. Well, so I'll just remove the IC and we'll put it back in again. And we'll see if reseating it back in will fix the problem or not. Right, let's turn this back on. See what happens. Still nothing yet. Touch over there, it comes on. Oh dear. So I don't think it's a physical connection problem. I think it's me radiating a signal into the chip off my finger. Let's do this again. So I want to do it without even touching it. Yep, didn't even touch the chip. That's not good. So I've got quite a strange behaviour on this. I've managed to narrow it down a bit more. Turn the power on. Got to do this carefully without touching main stuff over here next to it. So I've got a screwdriver here, which I'm holding at, right at the end, so my finger's not influencing it too much. And if I bring it across the chip, if I go to the crystal even, it goes on. Now if I hold the screwdriver a little bit further down, also I wasn't a bit too far away, go across the chip again, just there. Right at this point on the chip, I think it's about pin 8 or so. I think I should have pin 1 up here. I think it's about pin 8. And if I do the same thing to the crystal, it starts up as well. I'm wondering if this crystal is not oscillating. The crystal's not oscillating, that'll explain why it's dead. So I thought I'd better check the pin out on this microchip, because it's a microchip PIC here. It's a PIC 16F877A, I think it looks like, -I/L, apparently, on the next row down. So I'm going to check the pin out of that, but I bet you that fourth pin down there is going to be something to do with the crystal. I've got my guarantee it. Don't forget to click like and subscribe. Back to this. Now I'm going to test continuity between the crystal legs. So let's try and get this on my... I'll do it this side, shall we? So you can see what I'm doing. So probe on there. Let's check these pins up here, see which one actually connects up. Oh, there you go, third one up, connects to that side. Fourth one up, connects to that side. Okay, so third or fourth pin up, connected to the crystal. Well, that's matching my theory so far. Now, after looking at the data sheet, also that confirms that those two pins there are indeed the oscillator connections, which are actually pin 14 and pin 15. So, yeah, that all ties in. So putting a screwdriver next to those pins makes it come to life. Putting it near the crystal makes it come to life. So for some reason, this isn't oscillating. Now, with that screw floating around in here, maybe it's shorted out and damaged the crystal. May have made the crystal weak, or maybe it's fractured a solder joint. So what I might do is try resoldering stuff. Now the problem with that is that if I resolder it, it's going to heat it up, obviously, and it may actually change the way the crystal is behaving. So it could be still faulty, but it might hide that fault. It's a 4 MHz crystal. I may have something suitable to replace it with, so I might just try resoldering it, see if it changes anything. It may not fix it, it may actually make it worse, who knows. Give it a chance to flow right through underneath it. And do the same on this side, which you won't be able to see, I don't think. Maybe? I don't know. We'll just see if this changes anything or not. I might just do these capacitors too, because why not from here. Oh, let's power back up. It's still warm. No difference with it warm. Put a finger near it, it comes back. That didn't solve it. Next test, we'll try some freeze spray instead. Let's plug it back in. Switch is still on. Alright, let's try a bit of freeze spray on the crystal. Instantly came on, but it could have been because of some proximity. So what I'm going to do is just cool it down. And we'll do it again. We'll unplug it, plug it back in. Oh look, came on. There you go, it's giving error messages because there's nothing plugged in or anything, which is normal. That means it's booted up properly. So just by freezing that area of the board, it's brought it back to life. That's a good sign. It means that the microprocessor might actually be okay. Let's plug it back in. Let's come back to life. Excellent. There we go. Right, what I might do then is try heating that back up, and we'll see if it dies. Well, it's still running. Hasn't stopped it oscillating. Okay, let's unplug it, plug it back in again. What? Still alive? Interesting. So I would have thought it'd be temperature related. I'm thinking that's a bad crystal. Let me see if I've got any one to replace it with. So remove that crystal, let's put some flux on it, we'll clean it up a bit and then we'll put the new one down. Well, it's not actually new, it's a replacement, it's a new old one. I pulled it from something else. So it's probably works. I've got flux everywhere now. Well, I've replaced that crystal, let's see what happens. Oh, powered up, that's a good start. LEDs are running, okay. Seems to be working. I'm going to let this sit ambient temperature for a while because obviously the temperature's all a bit skewed because it's been soldered and everything, so I'm going to let it sit for a while and I'll try it again once it's at ambient temperatures again and we'll see if it still works, but I'm hoping that's it. Right, it's now been about half an hour, so it's all settled down, there don't be any temperature gradients there. Just plug it back in. It's still alive. I should put this thing back together again and carry on with the other testing and make sure the rest of it's actually working like it should. Right now it's giving errors because it's not plugged in half the stuff. Let's put this thing back together again. Put these little fibre washers on. I've already put this board back in again, and also I've already done all those screws up, so it should all be good again for a while. But yeah, it's interesting the way that was done like that. Something to have to watch for in future. I think next time I get one of these is actually check out those screws, make sure they're not falling apart, because maybe they could have even been loose last time I worked at this thing. But when I looked at this previously, I never even pulled the boards out, didn't need to, because it's all top side, it's just these wires here, it was on the other end that I worked on and stuff like that. So something to watch out for on these things. If you have one of these things and it's being a bit funny, or you find that random screw in there, now you know where it comes from. I think that's probably a result of that screw coming out though. I'm sure it's shorted across something and damaged that crystal. Because they do have power go across them, you know, so that's the way they work, but certainly an interesting fault. Never expected to find something like that. Let's put it back together fully and see if it works. Alright, here we go. It's basically back together. I've still got 4 screws out. I haven't finished fully assembling it yet. So just enough to hold the casing together. Hooked up to my original setup I've got here. Before I put the cover back on again, I checked the continuity on these leads to make sure they weren't broken. They seemed okay, but we'll find out when we actually do proper testing. Turn it on. Green light. It should detect the load I've got here. It should detect that's there. There we go. Symbol, which means go. It's detected the coil. So I should be able to then turn this on by pushing the button around here, and it will put out a voltage, which we should see on the multimeter, and it should work. Let's do it. It says it's going. It's putting out power. 105 volts coming out, thereabouts. 104 volts. That's fine. That's working. Excellent. Don't forget to like and subscribe if you find these videos interesting. That was definitely an interesting fault. Radiant field from my finger started an oscillator. Pretty random. Don't forget to check out the playlist at the end here. You've got one down here which is probably recommended by YouTube. This will probably be the playlist for the other Electrofusion units. There's a Patreon subscribe link up here which allows you to support the channel, and a more subscribe link there, or maybe the other way around, something like that. Check them out. Bye.